Okay, let's look at finding points of inflection and intervals of concavity where it's concave up and concave down using the second derivative test. Okay, so what we're going to find here is we need to get to that second derivative. Now, you can do this by hand, which actually I'm going to go ahead and do that, but then I'm going to do the rest of the process with the calculator just to kind of speed it up. So if I found f prime of x, right, that would give me 4x cubed minus 12x, and then if I go again, I'm going to have 12x squared minus 12. Okay, so if you look at this, right, you can actually keep going by hand here. This is not that bad. 12x squared minus 12 equals 0, and that's going to give me 12x squared equals 12, so x squared equals 1. So x equals plus or minus 1, right? Those are going to be my points of inflection, or they're going to be my x values. But let's use the calculator so we can kind of speed this up, and then when we're testing, it's going to be a little easier. So we need to find next, we need to find if these are the points of inflection, and we have -1 and 1, well, we need to get the y values, right? So let's use our calculator, and we're going to start with f of x. We're going to go ahead and save it or store it, either way. So we got here, we have this, and we're going to store it as f of x. And then we're going to go menu, calculus, find the derivative. Got to go through the first derivative if we're going to get to the second. And so we're trying to get g of x. Here's our derivative, so we're going to store that as g of x. And now we're going to go one more level. We're going to go menu calculus again and get the derivative, and that is going to give us, as you can see, our second derivative here. I'm going to store that as h of x. And remember, if you went menu algebra solve, you could go ahead and set your second derivative equal to 0, which is going to give you the x values of the points of inflection. All right, so now I got my -1 and 1. Well, remember, whenever we're finding maxes or mins with the first derivative test, or in this case, second derivative test, we need to input our x values into the original function to get the y value. So if I put that in the original, it actually gives me 0, and a lot of times, depending on the graph, the inflection points are the same y values because they happen halfway in between maxes and mins, right? So in both cases, we got a y value of 0. So let's go ahead and record that. So now we've got our points of inflection. And now we need to use the second, now here's where we actually do the second derivative test to figure out where it's concave up and concave down. So I know I got x equals -1 and x equals 1. And so I'm going to go back to my calculator here, and I just got to test values before and after -1. In between, so between -1 and 1, before -1, and then after 1. So I'm going to go with -2 here. That's going to give me a negative number, and it should alternate here because it's just a basic polynomial. Now you get 0. Oh, that's a problem, right? Notice that when that happens, well, that's not positive or negative, right? So that doesn't really help me. So actually, you know why we're getting wrong answers here is because we got to put it into the second derivative. So we're going to go second derivative here, go back here, and we're going to get positive number. Okay, so we got h. So don't make the mistake I did, right? I did first derivative here where I'm doing second derivative test, and that's how you know you got to put it into the second one. Now when I put in 0, this should actually work. So yeah, we get a negative number. And if I test 2, which is after 1, I'm going to have a positive number. Okay, so going back to our work here, we have a positive, negative, positive, meaning the graph is going to be positive, negative. Oh wait, let's see. Yeah, that's right. Positive, negative, positive, meaning we got f of x is going to be concave up on negative infinity to negative 1, and then again from 1 to infinity. F of x will be concave down just in that middle section from negative 1 to 1. Okay, and now we're done with this one. We've got our points of inflection and we have our intervals of concavity, and now you're done with the second derivative test.